Hello everyone, I'm Mathieu Granzotto, and my and colleagues' L4DC work is entitled When to Stop Value Iteration, Stability and Near-optimality versus Computation. When controlling complex systems, the existence of perturbations are expected, and it may be vital for the controlled system to behave similarly to the unperturbed system. This robustness guarantee is then also important when generating control inputs with a reinforcement learning scheme. This is our aim, and the approach that we take is by analyzing the dynamic programming methods that power reinforcement learning. We do so in a deterministic and model-based setting, and leave for future work the added complexity from learning. In this setting, robustness follows from stability guarantees plus some mild regularity properties. While there are several works that study stability and dynamic programming methods, there are still open and important questions. For example, consider value iteration, VI. VI is iterative and generates value functions by employing a Bellman update rule that also generates an associated policy. In the literature, it's usual to give conditions such that the above scheme converges to the optimal value function, and also that the optimal policy endows stability guarantees to the controlled system. However, since convergence of VI is asymptotic, in general, we have to stop at some finite iteration without obtaining the desired optimal value function and inputs. The problem is then how to quantify possible effects of stopping VI with a finite D. In our L4DC work, we study families of novel and some existing but ad hoc stopping criteria for VI with qualitative guarantees for near optimality and stability. We show which stopping criteria guarantee termination, relationships of near optimality, stability, and performance versus stopping criterion, and robustness guarantees. Feel free to pause and read a summary of our work in the poster with an application on an example, or if you prefer, all the details and generality are in our paper in the description. Thank you for your time and see you at L4DC.